we have 4 raised to power x minus 2 raised to power x equals 12. So 4 can be written as 2 raised to power 2 raised to power x. So this, using law of indices, 2 times x can be written as x times 2. That is, we can write this as 2 raised to power x, then raised to power 2 minus 2 raised to power x equals to 12. So by bringing 12 to this side, we have 2 raised to power x raised to power of 2 minus 2 raised to power x minus 12 equals to 0. Factorizing, we have 2 raised to power x raised to power of 2 minus, in place of 2 raised to power x, we can write 4 minus 3 there. So 4 minus 3 will give us 1. Then multiply by 2 raised to power x. 1 times any number equals to that number, or 1 times something equals to that thing. So minus 12. Then 4 by minus 3 will give us minus 12 equals to 0. We have 2 raised to power x raised to power of 2 minus open bracket with this 4 raised to power, that is 4 times 2 raised to power x, then minus times minus is plus 3 times 2 raised to power of x minus 12 equals 0. So solving further, we have, so between the first two terms, 2 raised to power x is the common factor. We have 2 raised to power. This can be written, this expression on the left hand side there can be written as, the expression on the left hand side can be written as 2 raised to power x raised to power 2, then that will be 2 raised to power x times 2 raised to power x, then minus 4 times 2 raised to power x, then plus 3 times 2 raised to power x minus 12 equals to 0. So the first two terms, 2 raised to power x is the common factor. By factorizing 2 raised to power x out, we have 2 raised to power x, then minus 4. So 2 raised to power x is left here, then minus 4 is left here. Then the last two terms, 3 is a common factor. So 3 from here we have 2 raised to power x left, and 3 from 12 we have 4 equals to 0. So we have 2 raised to power of x minus 4 is a common factor. Then we have 2 raised to power x plus 3 equals to 0. So therefore, 2 raised to power x minus 4 equals 0, or 2 raised to power x plus 3 equals 0. So we have 2 raised to power x equals to 4, or 2 raised to power x equals to minus 3. So therefore, 2 raised to power x equals to 2 raised to power 2. This cancel this, or by taking log on this side, then this is the real solution. Then we have the complex solution here. Taking log on both sides, that is natural logarithm will be the ln of 2 to the power of x equals to the ln of minus 3. Now we have x equals to 2, or then here we have x ln of 2 equals to, the ln of minus 3 using logarithm can be written as ln of minus 1, then multiply by 3. So simplifying this further, we have x ln 2 equals to ln of minus 1, then multiply things to addition in plus ln of 3, which imply we have x equals to ln of minus 1, then plus ln 3 divided by ln 2. Now solving this further, according to Leonard Euler. That is, according to Leonard Euler, when he was alive, he invented a formula. So that the formula is the complex, that is e to the power of pi I equals to minus 1. So e raised to the power pi I equals to minus 1. That's according to Leonard Euler. So now, this is the equation of Leonard Euler, where E is said to be Euler number. So E equals to Euler's number, which is approximately 2.7 to 1 decimal place. Now, solving further, we have So by taking ln on both sides of this equation, we have ln of pi I equals to ln of minus 1. So which implies, then by taking pi I to this side, we have pi I ln E equals to ln of minus 1. So ln of a logitudine of a number to its base equals 1. Therefore, we have pi I times 1 equals to ln of minus 1, which implies, so ln of minus 1 equals to pi I. So therefore, the complex solution to the equation we are given, so x equals to 2 is the real solution. Then x equals to, then we are going to substitute in place of ln of minus 1, we are using pi I there. So we have pi I plus ln 3, then divided by ln 2. But this has many solutions. So because we are in the complex word now, so it has many solutions, that is, so at every 2 pi, so we have another angle, so which is equivalent to pi. So that is by adding pi I to, or by adding 2 pi to pi I, that is 2 pi I to pi I at every k, then we are going to have the same result there. So when you have angle 20 and you add 360 degrees to it, when you evaluate any trig ratio, you must have the same result. So when you have theta to be 20 degrees, theta can be 380 degrees, theta can be 740 degrees. So this is when 360 is added to theta. This is when 720 is added to theta. That is 2 theta, that is 2 by 360 degrees to theta. So therefore, we have x to be, so x equals to, then in place of pi I here, we are using pi I plus 2 pi I multiplied by k plus ln 3 divided by ln 2. So that is, we have pi plus 2 pi k, then everything multiplied by I plus ln 3 divided by ln 2, where k can take its value from 0, 1, 2, 3, 4, and so on and so forth. So this is the complex solution to the equation we are given, complex solution. So there are infinitely many complex solutions, but there is only one real solution to the question. That is the deduction that can be made from this solution to the question. Thank you. Here k equals to 0, 1, 2, 3, 4. So when you substitute, then you have, when k equals to 0, you have one solution. When k equals to 1, you have another solution. When k equals to 2, you have another solution. When k equals to 3, you have another solution. So therefore, the implication here is that there are infinitely many complex solutions to the question we are given, but there's only one real solution to the question. So thank you. Therefore, the real solution is x equals to 2, while the complex solution can take any result when k equals to 0, 1, 2, 3, 4, so 5, and so on and so forth. Please like, comment, follow our page, share and subscribe to our YouTube channel for more educational content. Thank you.